Good morning. I am Ambika, Assistant Professor in Department of Computer Science and Engineering. Today we are going to discuss a topic in cryptography and network security. Before we discussing about the cryptography and network security, we have to know what is network security and why we have to know about network security. As we live in a digital world, we all transferring our data and our money in a digital format. Before we are sending it in a digital, we have to ensure that whether that network is secured or not. For ensuring that the network is security, here we are using a technology called cryptography. Cryptography is nothing but it ensures the sender and receiver whether they are the original sender and receiver. For secure communication, we are using the three terms: secrecy, authentication and message integrity. Secrecy is nothing but if we are sending a message in a secret way, the sender and receiver should understand the message, then only it will be secret. Authentication is nothing but the sender and receiver should ensure their own identity. That is nothing but they have to prove that I am the owner of that message. Message integrity is nothing but they have to ensure that the original message is received by the receiver. Then what you mean by cryptography is hiding a message or hiding a text into a image or hiding an image into a text is known as a cryptography. In cryptography, it has two main components. The first component is encryption. Encryption is nothing but it is hiding a message into a image or hiding an image into a text. That is converting the message which is in a readable format into a unreadable format is known as a encryption. Authentication and integrity is nothing but the sender and receiver have to prove that they are the original sender and receiver. Integrity is the sender should ensure that the message is not altered and original message should read by the receiver. Then the technology behind that encryption is nothing but here the plain text is a message which the sender wants to send. For making it in a secure format, the sender using an encryption algorithm, for encrypting, that is to convert the readable message into an unreadable format, they are using an encryption algorithm. For this encryption algorithm, they are using a key. Once the message is encrypted, it is converted into a cipher text. Then receiver to read that unreadable message, he have to use that decryption algorithm using a key to read that message. For this, a real-time example is nothing but our Gmail. If I am a sender, I am sending a message by using my username and password to that sender. The sender have to read that message by entering his username and password. The sender's password is a key and receiver's password is known as a key B. That is the technology behind the encryption. Then there are two types of encryptions. One is a symmetric algorithm and other one is a asymmetric algorithm. Symmetric algorithm is nothing but if sender and receiver both are using a same key, then it is known as a symmetric algorithm. Asymmetric is nothing but if sender and receiver using two different keys, it is known as an asymmetric algorithm. The Gmail comes into the asymmetric algorithm format. In this, it has two types of ciphers. One is a block cipher, the other one is a stream cipher. We know that block consists of 8 bits. In that, one block consists of 64 bits or 28 bits. In our lower classes, we have studied that word contains 8 bits, right? In here, each block contains 64 bits. And stream zipper is nothing but, we have known that the meaning of a stream. Stream is nothing but a river. So it has so many bits. Here we have to encrypt strength. Here we use, if we increase the key size, the security will be high. If we decreasing the key size, the security will be very less. If a hacker want to hack data or a message which is encrypted using a symmetric key encryption, he have to use the technique called brute force technique. It is nothing but if we are using a 56-bit key, then he have to try all the 56 possibilities to hack that key. Then the type of symmetric zipper is a substitution zipper. This is nothing but if your message is A, B, C, D, E, F, G, then your key is known as 3. Then you have to check for A, B, C. For A, for A, if your key is given as 3, you have to read B, C, D. Then for A, you have encrypted, A is encrypted as a B. Likewise, B is encrypted as a C, D, E. Likewise, you can encrypt in a Caesar zipper. The Caesar zipper is used in a ancient time for encrypting the messages in a war. Then in substitution zipper, I told that key is a 3. For A we have counted as B, C, D, right? For A it is D. T, then you have to count for 3. T it is encrypted as a W. For A again it is encrypted as a B. Then the next type in a substitution cipher is monoalphabetic cipher. Here we can encrypt a word with a single alphabet. In polyalphabetic, we can encrypt the same letter with 2 different letters. In monoalphabetic, we have encrypted A with only D. In polyalphabetic, we can encrypt A with F and T. But here we have to use 2 different keys. For first one, I have used a key as 6. In second one, I have used as a key as 20. Then transposition cipher. In this type of encryption, the message is written in a column wise. For example, if your plain text is this is a message to show how columnar transposition works. Then if I want to convert it as a cipher text, I have to convert this column to row. I have to convert this column to row. For example, TSSOHOANIW is written as a column. You have to convert it as a row. This T is written as here. This S is I have written here. This S I have written here. And O I have written here. Likewise, you have to convert this column into row. In decryption, you have again convert this row into column. Then you will get a plain text again. You can read that at a receiver side. Next technique is a cryptanalysis. Cryptanalysis is totally different from cryptography. In cryptography, we will convert that plain text into a cipher text, right? In cryptanalysis, what we will do is we have to divide the message into different parts, and we have encrypted in block wise. Then we have to combine. Here the blocks can be encrypted in multiple encryption techniques. Here we can apply block cipher or stream cipher. Like that we can apply any algorithms to encrypt that. The best example for in cryptography is DES. In real time, this DES algorithm is implemented in many applications. DES is nothing but data encryption standard. It will convert the message into a unreadable format using a encryption algorithm which is more secured because the plain text used here is always 64. If your message is more than a 64 bit, it has a technique to convert it into a 64 bit. For 64 bit plain text, we will always use a 56 bit plain text. Here, how the DS will work is, I already said that your plain text contains 64 bit. First, you have to divide that 64 bit into a 34 bit left side and 32 bit right side. Then you have to convert that 56 bit key using a S box as a 48 bit. Then you have to append this right 32 bit and that key. Then apply encryption algorithm. You will get again 32 bit to block. Likewise, you have to do this process as a 4 rounds. Then finally you will get a ciphertext. So as we doing the same process again and again, the security will be high in this part.